Good morning, everyone. My name is Liang Ting from Shandong University. Today, we'll start a new lecture called Basis of Molecular Nuclear Medicine. It means from then on, we will focus on the most important part of the molecular imaging, molecular nuclear medicine. Why molecular imaging in nuclear medicine is most important? We used one sentence from the Journal of Nuclear Medicine to answer this question. Because nuclear medicine is inherently molecular, we are poised for a pivotal role in future medical advances. In this lecture, I will talk with you about three different parts. First part, basis of nuclear physics. The second part, the mode of the radioactive decay, and the last part is the interaction of charged particles and the interaction of the photons with matter. Now, let me introduce the first part, basis of nuclear physics. If we want to discuss the characters of the radionuclide, we should first review the atomic structure. As you see in this photo, the atomic nucleus is the small, dense region consisting of protons and neutrons at the center of the atom. Protons and neutrons look like little balls. They stacked together by using quantum mechanics. Protons and neutrons made up the small, dense nucleus of atom. The mass of proton and neutron is quite similar. Electrons circulate around the nucleus in orbits. As for protons, they usually have a mass of 1 unit and have a charge of +1. As for neutrons, it also have a mass of 1 unit and have a charge of 0. So as for the electrons, they have a mass roughly 0.1% heavier and a charge of a -1. So here we showed us the symbol of atomic nucleus. As we seen in this picture, you can find the capital X. It represents the element name. And the capital Z, you can see on the down left of this picture, it is called the atomic number. It represents the number of protons. As for capital A, you see on the upper left of this picture, we call it the atomic mass. It represents the total number of protons and neutrons. Next, we need to distinguish several basic conceptions. The first one is the nuclei. What it means of the nuclide? It is identified by an exact nuclear composition, including the mass, the atomic number, and the energy. For the same nuclide, the proton number, the neutron number, and the energy state must be identical. So in other words, the proton number, the neutron number, and the energy state are the three main elements for the nuclide. Another conception that needs to be distinguished with the nuclide is the radionuclide. This means unstable or radioactive nuclide that undergoes radioactive decay. The next couple we need to distinguish is the isotope. The first one, isotope, nucleus with the same number of protons but different numbers of neutrons. We called this one the isotopes. For example, as seen in this picture, there were 3 isotopes of hydrogen. The first one, protium. The protium, there is only 1 proton in protium. As for the deuterium, It composed by one proton and one neutron. And the last one, the tritium, it composed by one proton and two neutrons. The next concept should be distinguished from isotope is isomer. The nuclei have the same number of protons and neutrons, but differing in energy state. We called this nuclide isomer. For example, technetium-99 and technetium-99. These are two nuclei having the same number of protons and neutrons, but they're in different energy states. Technetium-99 means it's in a metastable state, while technetium-99 in ground state. Okay, we have mentioned the radionuclide undergoes radioactive decay. So next we talk about units of radioactivity. Radioactivity is quantitatively measured as a number of atoms that disintegrate per unit time. Two different systems for expressing radioactivity. The first one is Curie, and the other one is Becquerel. The Curie was named in honor of Marie Curie. This unit was based on the disintegration rate of 1 gram of radium and was defined as amount of radioactivity that decays at a rate of 3.7 times 10 to 10 disintegrations per second. Here, we show the conservation relationships between Curie and DPS. An alternative to Curie in international system of units is Becquerel. It was named in honor of Henry Becquerel, the first person to identify radioactivity in 1896. 1 Becquerel equal to 1 DPS. So here we showed the conservation relationships between Curie and Becquerel. Besides the radioactivity, there is another special indicators for describing one radionuclide. It's very important, half-life. The half-life is the time required for half of a radioactive sample to decay. Each radionuclide has a unique half-life. The half-life is constant but is different from each isotope. Half-lives range from extremely short, such as fractions of seconds, to millions of years. There are three kinds of half-life. The first one is physical half-life, and the other one is biological half-life, and the last one is effective half-life. As for physical half-life, it is to describe the time required for half of radioactive sample to decay. As for biological half-life, it is to describe the biological clearance of the radionuclide from particular tissue or organ system. The last one, effective half-life. Actually, half-life of the radiopharmaceutical in biological system, which it is means depend on both the physical half-life and the biological clearance. The relationship between them and the effective half-life is given by the following formula. So one point in particular needs to be emphasized is that physical decay and biological clearance occur simultaneously in parallel. Okay, that is all for the first part. Thank you.